friends, today I am now going to discuss about the nuclear transitions. So let's start. Nuclear transitions, there are two types of nuclear transitions. One is allowed, another is not allowed or forbidden. So according to nuclear transition, there are two types, allowed or forbidden. So what are the allowed transitions? Allowed transition is actually specified as the transition where L equals 0 and beta particle and neutron emits. That means for allowed transition L equals 0, that is, what is L? So for allowed transition we have seen that L equals 0 and beta particle and neutron exist. And for forbidden transition we can say what? For forbidden transition, L not equals 0, that is angular orbital momentum not equals 0, and L equals 1 means what? First forbidden. L equals 2 means what? Second forbidden, and in such a way. So in case of, now we are going to identify whether in case of allowed transition, Fermi transition, or there are two transition, another types of transition. Not in case of only allowed, another types of transitions are Fermi transition, and another types of transition is GT transition, Gamow-Taylor transition. So in that case we are now going to see that whether in case of allowed transition, this Fermi transition and GT transition, Gamow-Taylor transition, allowed or not allowed. Okay, so how to check Fermi transition and GT transition, Gamow-Taylor transition exists and with the properties of them. For Fermi transition, only remember some specific properties of the Fermi transition. What are they? For Fermi transition, we can remember the properties that here for Fermi transition, both electron and neutrino both emits with what? With opposite spin. Electron and neutrino have both opposite spin, and that is the reason delta S, that means change in spin, is 0. That is delta S is 0. And for allowed transition we are checking that for allowed transition Fermi transition will be allowed or not. So for L equals 0, delta S equals 0 also, and L equals 0 also. So combining, what we will get for Fermi transition? Allowed Fermi transition we will get delta J equals 0. And for Fermi transition, another thing we will get no change in parity. And another thing, 0 to 0 transition. 0 to 0 means J value 0 to 0 transition is allowed. So again I am just telling. So for Fermi transition, what we will see? We will see that electron and neutrino particle both emits, both with opposite spin. For both, as opposite spin, delta is equals 0. As delta is equals 0 and L equals 0 for allowed Fermi transition I am saying. So that is why we can say that delta J equals 0. Delta J equals 0. And another property is no parity change for Fermi transition. Allowed Fermi transition, no parity change. And another property is 0 to 0 allowed. And for allowed transition we will see how GT will be allowed, that is Gamow-Taylor transition will be allowed. GT transition, for GT transition we will see another some specific property. For GT transition, what we will see? Both electron and neutrino emits, both not opposite spin, now parallel spin. As parallel spin, so we can see what? Both delta is equals 1, that means change in spin angular momentum is 1. Now as delta is equals 1 and L equals 0, so what we can say? We can say that delta J for gamut GT transition, allowed GT transition, means when L equals 0, delta J could be 0 plus minus 1, and here in this case also no change in parity, but the valuable thing is, important thing is, for GT transition, GT transition, GT allowed transition, 0 to 0 not allowed. So this is the some properties how to check Fermi transition and GT transition in case of allowed transition. So we are now going with an example. So here 0 plus electron neutrino. So here what you can see, here J value 0, J value 0. Electron means beta particle and neutrino both emits, that it could be either Fermi or GT. But how can we say that it will be Fermi or GT transition? Here J value is 0, that means delta J is 0, and L value is 0, that means delta S is 0. Delta S is 0, but the main thing we can say here, I'm again writing, in this case 0 plus electron in neutrino. This is beta particle, this is neutrino particle. So how can we say that it is Fermi or GT? We have told as a property that for Fermi transition 0 to 0 is allowed, and for GT transition 0 to 0 not allowed. So here 0 plus to 0 plus, that means only here Fermi transition is allowed. That means here Fermi transition is allowed. 0 to 0 plus means, here what is a 0? You can say 0 is J value. J value is 0. That means 0 to 0 plus is allowed. That means what? If here it was given 1 plus or 1 plus, you can ask that means here also is delta J is 0. Then here what we can say? Here also is delta J is 0. But here it is not 0 to 0 transition, na? So here, as it is not 0 to 0 transition, here we can see that delta J is 0. Delta J is 0 possible for Fermi transition always, and for GT transition also delta J equals 0 plus minus 1, selection rule that is. But for GT transition, what is the main thing? For GT transition, the main thing is 0 to 0 is not allowed. So in that case, here it is not 0, here it is not 0. In that case, both Fermi and GT both can be allowed. So I'm again writing clearly that example 0 plus, that means it is J1 value, 0 plus, it is J2 value, it is in reaction, plus electron, that is beta particle, and neutrino. So electron and neutrino both emits means what? Whether it is allowed Fermi transition and allowed GT transition, but what will be that? But here J value is 0, J value is 0, that means here 0 to 0 transition is occurring, na? So 0 to 0 transition is occurring means here it will be, it will be Fermi transition. It will be Fermi transition. I am taking another example, allowed Fermi transitions. Another example is that if I take 3 by 2 plus electron plus neutrino. So 3 by 2 plus electron plus neutrino. Here also delta J is 0. That means 3 by 2 and 3 by 2 0. Parity change. No parity is changing. Here also plus, here also plus. Electron and neutrino emits. That means here delta J is 0. No parity change. That means electron and neutrino is also emitting. That means both. That means what? But here you cannot see one thing. You can check here one thing. Here J equals 3 by 2. But here one thing is crucial. Here it is not allowed. Why it is not allowed? Why it is forbidden? Both forbidden transition. Why? Because basic thing is what? For allowed transition, basic thing is that L should be 0, and this is allowed. And for forbidden transition, basic thing is what? L not equals 0. This is for forbidden transition, and that is 3 by 2 plus to 3 by 2 plus. That means what? J value is 3 by 2. J value 3 by 2 means what? Spin is opposite. Spin is always half. That means L value is 1. L value 1 means what? L value is 1 means L equals 1 means not equals 0. L not equals 0 means what? That is forbidden transition. First forbidden transition. That means 3 by 2 plus to 3 by 2 plus electron plus neutrino. This is not allowed. This is forbidden transition. First forbidden. So we will discuss more in this case in our next videos. For the time being, thank you so much for watching.